Hi, my name is Jason Chanko and I'm the Applications Engineer at SIGLENT Technologies. In today's video, we're going to look at a new firmware enhancement for the SDS 1000X-E series of oscilloscopes. This firmware revision is 6.1.37R2 and was released in mid-August of 2021. This particular feature, or this enhancement, is one of the main enhancements, and we'll take a look at some of them as we go along here. But the main enhancement is going to be a data logging feature. And with normal oscilloscopes, every time you get a trigger event, it's going to collect a certain amount of data and send that to the internal memory. That can be very helpful, but on very long time bases, let's say we wanted to collect data over minutes or hours or days, that standard architecture isn't very helpful or isn't very easy to use necessarily. And so our firmware designers have gone to some lengths here to build a data logging feature, and that's going to allow the oscilloscope to write directly to a USB stick or to the internal memory so that we can acquire data over very, very long time periods. So I'm just going to go through some of the features. It's very helpful if we're going to be doing trending or you want to see the events over longer periods of time. Again, if it's minutes, hours, or days, this is going to be a very helpful feature for you and collecting that information. So mimicking a longer output supply, I've just got one of our SDG800s here. It's just going to be outputting a square wave sweep. I'm going to insert a USB stick. So I've already updated the firmware on this particular unit. I'm just going to insert that. It's a FAT32 formatted stick. And you'll see that it's been detected. And you'll also note here, let's just cover some of the new features. So I'm going to press Utility, and we'll press Page, and you'll see that we've got some new buttons here. We've got Data Logger, Counter, Date Time. So first I'll cover Date Time. The new firmware and its new operating system, so there are two separate files that need to be installed. But once you've installed those, you'll see this timer. We've got date time that can be pulled, or we can manually set the date time and confirm that. And it's going to remind you it's going to be reconfigured after the start. So the X-E series of oscilloscopes do not have a real-time clock, and they don't have a way to store that after power down. So every time we set the date and time, if we power cycle the instrument, we're going to have to reset it. But that does allow timestamping on all of the files. So instead of just saying 1979 on every file that's been saved with the oscilloscope, it will have the real date and time that you have saved. We've got time zone. There's also NTP, which is the network time protocol. If the instrument's connected to a working LAN or working IP, or I'm sorry, working network, Ethernet network, it's going to automatically provide the system time in that way. So that's also another helpful feature with this particular setup. I have the display on. You'll see it located up here. It says the date and the time. Let's go back. Again, we're still in the utility menu. I'm just going to cycle through the next page. Now I'm at 2 of 4. Let's open up Data Logger. And now we have two types of loggers. We've got a sample logger as well as a measure logger. Sample logger is going to take individual analog input channel samples and save those. Measure logger, if I set up a particular type of measurement, peak-to-peak voltage for example, it's going to log those measurements in a separate file. So you can look at trending of a specific measurement over time. In this example for today, I'm just going to do sample logger. And you'll note that it set up everything. Now it's all ready to go. Basically, I want to go to record, and you'll see I have 2 seconds per time division. And we have the ability to change the rate. So we can do 50 samples per second. And you'll note that it also tells you how much time can be saved, or how much data can be saved in a time domain. So here it's 8 days at 50 samples per second at that time base. We can also change it to external. Now it's going to read that drive and give us an idea of how many samples we can save there as well. So now we've got 481 days. So again, FAT32, if we're going to be sampling small amounts of data, we can write that all day long. For 481 days, this is a 16 gig drive that's about half full. So anyway, it can save a lot of data that way. So we can adjust the sample rate here just by either pressing the button or by switching over. We can also change that file name. This is going to save a binary file to our USB stick. So it's all ready to start. I'm just going to turn on my, well, I'll start the acquisition. You'll start to see that the data will start to collect. Now I'm just going to turn on my source, and we'll let that run for a period of time. What I'd like to also show is some of the areas here. It's telling us how much time has recorded, our start date, and how much is still recordable, so our elapsed time until that memory stick is full. And again, we have that timestamp. It's also telling us the number of samples that we have up in the right-hand corner. So as it collects data, it's also going to automatically scale. So just kind of let it run its course here for a few minutes. You'll see that now it's changed to 4 seconds per division. We'll let it go a little bit longer. Now, so we could let this run again for days and days if we have enough storage. We can stop the oscilloscope at any point in time. Now it's going to write that data to the USB stick, and we're going to, as it formats everything and gets it all set, should be quickly coming back to life here in a sec. And now we're all done. So now it's written this file, the binary file, directly over to that USB stick. We can also recall that file, and we can adjust the horizontal time base. We can measure it with cursors if we want to. So we can recall any of those files that have been saved. We can always go back as well. And we can zoom around the center, or we can zoom around the right side and view all. So now we can go back to the original zoom. So again, in this way, we can save a lot of data. We can transfer it over to that USB stick directly and do that over long time periods. Again, for long time bases or long time duration measurements. Really nice acquisition capabilities. Instead of building a data acquisition system to do this, you could just grab your simple oscilloscope, plug it in with your sensors, set up your horizontal time base and the sample rate that you need, and hit go. Should be all set. Also, in this firmware revision, there is a tool with the X-E's, the 4 channels. There's a website or a web browser control embedded inside the oscilloscope itself is a binary to CSV tool. What that allows you to do is pull that binary to CSV executable to your local machine, your computer that's driving, and any data that you collect in this binary file format, including these new logging files, can be unpacked from binary and converted to CSV if you want to manipulate them even further. So maybe in a future video, I'll also cover downloading some of that information. So I hope you find this new enhancement to be extremely helpful. If you have any questions, please contact your local SIGLENT office. Have a great day.